Stop, please. These two. Does it ring a bell to anybody? Anyone? Yes, sir.
I've heard of it, but I don't know what it is.
Okay. Good. So it sounds familiar. That's nice. Any other person who has heard about these two guys before? Okay. Yeah, you too. Does anybody have an idea what each of them mean? Yes, one try.
It's like there's two numbers, and one increase and another one will increase. That's our proportional and inverse, like one increase, one will decrease.
That's perfect. In direct proportion, they are not, we can't say numbers, call them quantities. Okay? Two quantities. If two quantities are related by direct proportion, it means when one increases, the other will increase, like she said. Rita, do you mind just paying attention to me, please? And for inverse, when one increases, the other will reduce. I'll give you an example. In my family, say we are 10 in number. One variable is number of people in the family, we call that n. And the other variable is total amount of money we spend on a monthly basis. Okay? So, let's see. C and n. C and n are definitely directly proportional. You know why? Because if more people coming into our house, maybe family members come to visit. We're already 10 in number, mommy, daddy, and his children. Oh, okay. Maybe we make it 11, so it's like a football team. Anyways, mommy, daddy, and we have 9 children, so we are like 11 in number. Yeah, that's a football team. You want to beat that? Anyways, so if our cousins decide to come from wherever they live, they're like 5 in number. How many people do we have in the house now? 16. What happens to the cost at the end of the month for providing for everybody? Does it increase also?
Yes.
So you notice that the number of people in the house increase and the cost also increase, right? Now, let's say we have the football team family again. But maybe 4 of them are 18-year-olds and we just send them off to college. So let's pretend the college take care of them. We don't have to give them money anymore. How many people do we have left in the house now? 7. Those 7, do you think we're going to spend more or less than the usual? Less. So when the number of people decrease, the cost also decrease, right? So these two variables will be directly related. This is how we say it. We say C varies directly as N, or C is directly proportional. In fact, the word directly may not be used. To N. That's what it means. Is it that we say C is proportional to N? Whenever the word direct is not used, it's direct proportional. Does that make sense? So direct is when the two variables go in the same direction. One increase, the other increase. One decrease, the other decrease. Does it make sense? This relation, A is equal to pi r squared, is a direct variation. If I increase my radius, this is a radius, right? Now I decided to increase the radius and I draw another circle. The area becomes bigger. Does that make sense? So, but with this radius, I decide to reduce it, the area becomes smaller. Can you see that?
Yeah.
So the bigger the radius, the bigger the area. The smaller the area, the radius, the smaller the area. So this A and R are actually directly related, proportional. Okay? We will see what this means later. The pi, we call that constant of variation. Later we'll talk about it. But inverse is the opposite. Just like she said. When one increases, the other will reduce. When one reduces, the other will increase. Can somebody think of a practical idea in our day-to-day life where two quantities are inversely proportional to each other?
So there's less people in this class, we can eat more. So more people.
Very good. Say that again. Say that louder.
If there are more people in this class, we eat less stuff. If
Mhm.
there are less people in this class, we eat more stuff.
No, more people in the class, less stuff to eat.
Because when the food is constant, when we're more people, so we can
Oh, did you hear that? I said the food is constant. So every day we buy 12 boxes of pizza, for example. If you have more people in the class, you will eat less. Remember, the food is constant. You have 12 boxes now. We have 24 people, for example. So which means each person is entitled to half, because there are 12 boxes, right? Now, if you have, instead of 24 people, 12 people came to school, do you have more to eat?
Yeah.
Yes. But 24 people, then the other class from 3 standard came to join us, and there are 24. Do you think you can get up to half slice? No. That's what he's talking about. So the more people we have, the less food each person can get. And the less people we have, the more food each person can get. And that's an inverse variation. Guys, class is going on here, in case you don't know. Thank you. Do you understand that? So that's one. Another one, anybody? Okay, quickly.
When the area of the rectangle remains constant, the width increase, the length will decrease, and the width will reduce.
Good. Think of a rectangle. The area remains constant. If you stretch it further to maintain the area, the width will decrease definitely. That's another one. Now, let me give you one, and let's make that the last because of our time. I go back to the family thing again. But this time around, we're not talking about the cost and the number. We're talking about the number of students. Isaac, please stand at the back. We're talking about the number of people in the family and the number of days it took to consume a particular amount of food. So, you buy cereal on your dining table. You guys are 3 in the house. There's a particular number of days that cereal will last, definitely, right? If Alex decides to travel and there's just the parent at home, they will spend more days eating the same amount of cereal, right? Do you get my point? But if Alex was home and cousins came from mainland China to join, then they will consume the cereal in less number of days than the normal. Do you understand that? So more people in the house, less time to consume it, similar to the pizza example he gave us. Do you understand that? So these are inverse variation. So when you have a direct variation, you write like this. When we have inverse variation, we use something like this. It's proportional to the inverse. Okay? Do you get the idea? This is proportional to n, then this is proportional to the inverse of n. For inverse variation, the word inverse will definitely be used. Any questions? No questions? Okay. So how does this work mathematically? Let's go back to your seat, sir. I'll just take some random questions and that's it. I'll show you the steps and that's the end of it. It's a very simple topic. What topic, what page is that again? Can somebody check the time for me? 334. Yes, what's that?
11 around.
11 on the class at 11:30. All right, great. You can do it. 334. Okay, so let's look at this question on direct proportion. I will go to, there are a few steps that we want to see when you solve problems on direct variation. I just go with some example. Let's start with y is directly, I picked it from your textbook page. Can I just write the page and not the question? Is that okay?
Yeah.
All right, everybody go to page 337 of the textbook. Yeah, you can share with someone. Page 337 of your textbook. Question, let's be question 6. Page 337, question 6. Are you there yet?
Yep.
Okay. Have you seen question 6? Ready? Okay, so let's see. What does the question say? Can we read it together so I know everybody's there? What does the question say? Proportional to what? Cube root of x. Okay? Then what else? So let's take this one by one. That statement, this is how you write it mathematically. Y is proportional to cube root of x. Okay? And that proportional means directly proportional. When you get to that point, the next thing, so the first thing is to write proportional. Everybody please listen, some of you are busy writing now. You are going to end up doing the task I will give you in the way that I will not accept. And simply stand. At the back please, thank you. So y is directly proportional to the cube root of x, that's the first thing. The next thing is to have an algebraic equation that we are used to solving by changing this proportional sign to equals to. I'll give you a scenario. Because I'm about to write something that may look confused to people. Somebody sometimes ago, or some group of people sometimes ago, did some experiments. They pick circular shapes. Then they realize for every circular shape, like that, they look at the gap between, the longest gap in between the extreme, which is called what? Diameter. So, through the experiment, they realized that this part, which is the circumference, whenever they divide it by the diameter, they get a number that is approximately 3. Okay? Somebody picks another bigger shape. They found the circumference. Let's say this is C1. So it's called the circumference C2, for example. This diameter, maybe is D2. Then we realize, oh, it's also close to 3. 3 point something. Do you understand that? Somebody else, so there are a lot of these experiments going on, and we get 3 each time. Which means from here, my C1 is actually that 3 times diameter. Is that not?
Yes.
Talk to me, please.
Yes.
C2 will also be 3 times that diameter. Is that not?
Yes.
I just approximately 3. I'm not saying it is exactly 3. Okay? Now, because this number is a constant, although these two vary, the bigger the radius, the longer the circumference. Do you agree with me?
Yes.
If I want to write it in terms of language proportion, I would say C is proportional to diameter. But actually, the exact relation is that C is equal to 3 times diameter, approximately. This is where that formula C is equal to pi times diameter came from, through that experiment. Because pi is that constant. Why do we say pi is a constant? It never changes. Does it make sense now? But this is the relation between them. In terms of, oh, we know when one increases, the other will increase. But this is actually the exact mathematical relation. That pi, sorry, this one. Does it make sense? So there's difference between this. This is just like me saying, oh, when one increases, the other increases. But what exactly is the mathematical relation between them? Is it that one is twice the other? Is it that one is half of the other? And something like that. So the first thing is for you to write your statement like this. The next thing is to change it. How do we change it? We know that y will be a multiple of this. But we don't know what that multiple is. So immediately you introduce your k. That k, we call it k is constant. K is a constant of proportion, or constant of variation. Does it make sense? Any question? So this is, we know that when one increases, the other increase, but here is the exact relationship in terms of algebra. If this is 2, then we know y is twice this one. If this is 3, then we know y is twice of this one. Just like C is 3 times the diameter approximately. Am I making sense? So our goal in questions like this is to figure out what k will be, so we can get that exact relationship in terms of numbers. Am I making sense to anybody? All right. So let's see. Let's read the next statement. So the first statement takes us to this point. The next statement tells us how to find our k. What is the next statement?
If y equals 100,
X is equal to. So that gives you what your k is. Does it make sense? If y is equal to 100, X is equal to what? 125. So we solve this. So 100 is equal to what? K times 5. And with that, K will be equal to what? 20. Now that K is 20, what is the exact relationship between X and Y? Anybody? Y equals 20 times cube root of X. So this is the exact relationship. So any question that follows will be solved using this formula or relationship. So again, the first thing, write whether it is direct or inverse relation. The next thing, introduce your constant of variation. Then solve for the constant of variation. Then establish the relationship. Some question will tell you what is the connection between X and Y. This is what they're talking about. Some questions will tell you what is the relationship between X and Y. This is what they want you to write out. Some will tell you what is the formula connecting X and Y. It's the same thing you were talking about. It's just a matter of language. Am I making sense? Okay? So, can we now look at the next two questions? In that same question, there are two sub-questions. What's the first one? Find Y when X is what?
64.
So, now, I've not started my A, but without this preamble, I cannot do my A. When X is what? Again, 64, right? So when I have this, I go to the relationship. I know that 20 is cube root of X, so I substitute. So Y will be equal to 20 times cube root of 64. What is cube root of 64?
4.
So in that case, Y is equal to 20 times 4, which is 80. Does it make sense? Yeah. On the other hand, B, Isaac, please stand. Told everybody to pay attention. On the other hand, what is Y when given?
40.
Everybody?
40.
Alright? So you go to the relationship again. Y equals, you always go to the relationship. Always. Because you establish relationship for every X and Y in this problem. So you always start from the relationship because you have established them. Okay? So what is Y? We put it here. 20. So what do we do now? What do I do next? I've already substituted. There's nothing to substitute. Yes, Yanko was saying something.
40 divided by 20.
40 divided by 20, and that gives us 2. Agree?
Yeah.
So what do we do next?
Cube the 2.
You cube both sides. So 2 cubes. Any question? Rudy? And that gives us 8, not 6, please. Let's see if there was increase, decrease to establish that direct relation. What was the first X and Y? X was 125, Y was 100. In this case, X is 64, which means X dropped to 64. Did Y also drop? Yes, Y dropped to 80. Okay? In the second part, there was no increase, also decrease. Y was 100, dropped to 40. X was 125, dropped to 8. Does that make sense? So this is how we solve direct proportion question. You want to take it down? Let me look for one on inverse. Yeah, you can switch it off. Yeah. So I'll take one on inverse. Please sit, both of you. I'll take one on inverse, then, and that's the end, basically. Guys, can I ask you to stop because of the time? This can always be copied later. I need you to look at this question. Try to come up with a solution. Agree with someone beside you. Exactly the way we did it here. Can I ask you to do that in 5 minutes? But this is an inverse. Don't forget what I said about inverse. Okay? Alex, I told you to copy this later. Focus on this question now. Focus on that question now. Oh, okay. No, you can do the solution at the back of your note. I just want to see a sample of what the solution looks like. Alright? Just a rough idea. Particularly those aspects that I tick. Look at this. This part that I checked, I want to see how you write it for this one. Guys, this aspect that I checked, I want to see how you write it for this one. Can you quickly show me? You can write at the back of your notes. You can write on the scrap paper. Show me now. 2 minutes, everybody. Those three aspects in particular, work it up to that point and show me. 2 minutes. Raise your hand if you get something. I want to see the details working. I don't want to see final answers. Okay, the first part, the second part. Okay, what is it? Yeah, okay. I'm just going to point out something when I'm doing it based on my observation. Yeah, good. That bracket is redundant, which means it's not necessary. So, okay. Yeah. Alright, yeah, that's it. Yes, ma'am. Okay. It's inverse, Alex. It's inverse. Did you read the question? Inverse. Okay, I've seen that. Very good. What is this? Okay, so please listen now. We talked about, I mentioned inverse before. If C is inverse proportional to N, it will be like this. Okay, for inverse variation. So, which means, what is it? Can you read that first statement for me, please? Q varies inversely
with 5 minus 2.
5 minus t. Did you get that? Who wrote that? Yeah, that's the first thing to do. Okay? Then the next thing is to introduce k and change that to equality sign. So what do we have? Q equals, just write this.
1 is k. Yeah,
1 is not k. Remember, it's going to be k times 1 over 5 minus t, right? How do you multiply fraction?
Oh, yeah.
So you just put the k at the top. I think most people did it that way except maybe 1 or 2 people. So it's better written this way. Okay? So what are the values of q and k? Do you know? Yes?
Q is 8.
Q is 8 and t equals what? 3. So that gives this aspect 2, this area 2.
Isn't T 2?
Am I right?
Yes.
Did you get 16?
Yeah.
You got what? 16. So if you put it back, the relationship is q equals what? 16 divided by 5 minus t. And this is what you use to solve the next 2 questions. Can I ask you to finish that, please? Remember, k is a constant.
Q and T.
So complete the question. Then I will write some question numbers on the board for you to practice. And that's all about direct and inverse variation, basically. There are 4 types of variation, but for your syllabus, it's just 2 you have been tested on. We have what we call the joint variation and what we call the partial variation. Do you guys know this formula in physics? M1, M2, I think is G, divided by maybe R squared? No. Oh, okay, that's right. Something about gravitational law somewhere. I can't remember the
One
exact
is
thing.
M, but one results are proportional and physics.
Wait, hold on. Have you done gas law in chemistry?
Yes, yes.
Charles law, Boyle's law.
Yes, Boyle's law.
This, that's the language of proportion. So what I usually do is when I remember the formula, I can come up with, somebody writes in my exam, for example, state the Charles law. If I know the formula, then I can state it because it's about temperature is proportional to something, keeping something constant. And I can deduce which one is the constant, which one is very, and that's how I pass those things. Maybe my teacher think I memorize all of them. No, I just use math. Because I don't have time to memorize. One of them is, I think P1, V1 is equal to P2, V2. Is it? Am I right? Am I right?
You're correct.
Then one is P1 over T1 equals P2 over T2,
But
right?
this one volume.
Is it V over T?
Yeah.
Okay, this one is V.
This correct.
This one is correct?
Yeah.
And this one is also correct?
Yeah, but that one is like when volume is constant, so it works.
Yeah, exactly. So this is what I mean, guys. If this happens, it means this is always a constant. It's always a constant means 1 will be 2, 2 will be equal to 3. So if this is constant, it means, so this is what I do those days. If P1, V1 is a constant, it means my P1 would have been constant divided by V1, right?
Yeah.
Which means the pressure is inverse proportional to the volume.
Of course.
Do you understand? So once I remember this, I trace it back to this one, and I just write in my exam paper, the pressure at atmospheric whatever is inverse proportional to the volume, provided the temperature is constant. And I get all my marks, and my teacher thinks I memorize it and I'm, very smart. No, I'm just mathematically smart. I'm not chemically smart. And for this one, so I believe this is the constant, so then it will have been P1 is K times T1, right? What kind of variation is this?
Directly.
Direct. So the statement will have been the pressure is directly proportional to the temperature, keeping the other one constant. And I just write it in English, and I get all my marks. Oh yeah, very good. No, I'm not.
Why is K? Why does
K is not replacing 1.
No, K is the.
This is it. Remember, it should have been Q equals K times 1 over 5 minus T, right? So this is over 1. How do you do 2 over 3 times 5 over 9? Okay, you just multiply. So we multiply this by this, we multiply this by that. And that's how we got this. So when you have an inverse variation, from this point, just change it to equality and put K as your numerator. So that's what happens. Any question, please? No question? It's 11:29, which means we head now. However, can I ask you to write these pages down in your notebook? Because I don't want us to go to this topic. Of course, I'll give you a graded worksheet that we'll use in term 4 later. But in the meantime, please, everybody write down pages, okay, 335, pages 335, up to 341. So these are where all the variation questions are. So practice on your own, please. It's not homework, just because if you do not practice on time, you might forget what we talked about. So it's not homework. Alright? Thank you very much. Joey?
Sorry.